There we go. What's the matter? Oh, okay.
Good. All right, we're all good. So very quickly for the video, this is the warm-up, just taking the series and writing the answer. So you know what? Here, start video. Work on these. You have to write them as with sigma notation, and then determine if they converge or not. Pause. Do it. On pause. Here's all the answers. Okay, good. And we're just going to move on and get into the lesson. Feel free to ponder those by pausing the video. All right, so today we're finishing up section 9.8, and we're going to learn how to differentiate and integrate power series. So, the way that we start we were thinking, well, how can we differentiate and integrate a power series? It's not even a function, or is it, right? Okay, so the way that we do that is we're going to call f of x, let f of x be this series, right? Now you're thinking, but the input of a series is integers, and the input of a function is really usually all real numbers, right? Well, in this case, you can have both. This series, the input to the series are values of n, which are integers, but if we actually plug in all of the values of n, we're left with a function that's in terms of just x. The n's are all gone, and we're left with just x's. And then that can have any input we want. Of course, then determining if we wanted to converge or diverge, we might limit or restrict the input that we have, or the domain of our function. However, for the series, as far as the series is concerned, the input is n, and for the function, the input is x. Here's what I want you to do. I want you to take a minute, and I want you to write out the first 4 terms of f of x. And I'm going to get you started. To get the first term, you plug a 0 in for n. So your first term would be a sub 0 times x minus c to the 0. Alright, just plugging in the first 4 numbers for n. Go ahead and do that. The first for n equals 1, n equals 2, n equals 3. Write out the first 4 terms of f of x.
Yeah, I do.
That's it. Good. All right, check against your neighbor, see if you match. We all match for the first 4 terms. There should be pluses in between these, right? It's a sum.
Oh, I didn't think there were
Okay, good. So now if you've just written the first 4 terms, that's fine. Now write it using function notation. Write f of x equals, and write it as one long function, meaning you're adding all those infinitely many terms together. Do y'all see how I got these?
Yeah.
Yes? Any questions? Hey, what kind of a function is this? Okay, it's like a Taylor polynomial. It's a polynomial, right? This is a polynomial. In section 9.7, we learned how to take a series or take something and write it as a Taylor, I know it was, took something and wrote it as a Taylor polynomial. Now we're going to take a Taylor polynomial and write it as a sum. So we're going to kind of go a little bit backwards. But we're just going to call these polynomials because we'll just see. Alright, so it's just a polynomial. Now let me ask you a question. Since this is a polynomial, is it differentiable?
Yes.
Are you sure?
Yeah.
Is it continuous?
Yes.
So it's differentiable?
Yes.
Is it integrable? That really is a word. Can we integrate it?
Yeah.
So we can differentiate this and integrate it?
Sure.
Are you sure?
Yeah.
Yes, of course, of course. All polynomials, right? Okay. All polynomials can be differentiated and integrated, right? And integrable is a word, right? It's like differentiable. Good. All right, here's what I want you to do. This is your F. I want you to take a minute and write F prime. Now this is F prime of X, not F prime of C, not F prime of A. A and C, think of those as coefficients and constants, right? This is just in terms of X. X is your only variable. Go ahead and write the polynomial version of F prime. Once you get that, I want you to see if you can write F prime using sigma notation. Lynn, since you just got here, you can do it. Just the first term. Everything else is looking good. Oh, there you go. Now, trying this, you're very close. If this was, say, we just look at this term. Say this was x minus 5. So the one x minus 5 squared.
Stop. I know that's what you did. Yeah, it's just big. Wall. Guess it's Steve's fashion.
It'd be 2 times quantity x minus 5 to the first x minus 1. So,
All the cooked things like Lord,
and break it apart.
I want you to read
Coefficient
this
of 1, 2, 3, 4. Wait, write that. And then you have ace of 1, ace of 2. What did this feel like?
Oh, wait.
There we go. That's really good. Okay, let's take a look at your polynomial. How did you do with your actual derivative? Any questions on this? You use chain rule for these, right? So the derivative of a sub 2 x minus 2 squared is 2a sub 2 times x minus c to the first, right? The c stays because of chain rule. All right, good. So now effort to write this using sigma notation? Anyone not? Now's the time to admit it, you weren't?
I wasn't able to do it.
You weren't? Okay, so here's what I want you to do. Go ahead and write a sigma.
I got that.
You got that? Okay. It's always a good starting point, right? Okay, so you've got a sigma. Remember, for sigma, since we've got 1, 2, 3, I would start with n equals 1. Alright, so a sub 1, a sub 2, a sub 3 plus dot dot dot. How could we write that? A sub... Oh, there you go. A sub n, right? Because that's what we were plugging in, 1, 2, 3 for n. Look at the coefficients. The coefficients are 1, 2, 3, 4, 5. So what would be with next to the a sub n? Another n, right? You have n times a sub n, or a sub n times n. And then the last thing we have x minus c to the 0, x minus c to the first, x minus c to the second, x minus c to the third. So in general, you've got x minus c to the n minus 1. Yes, very good. Right? You could also start with 0 and do n plus 1, a sub n plus 1 times x minus c to the n, right? Whatever floats your boat. All right, any questions on that? I want you to look at something. Look at your original function in sigma notation. I want you to mentally differentiate this and think about what you get and compare it to the derivative you just found.
That's cool.
Okay? Do you all see it? Okay.
So shabby.
So, when you...
Savvy.
Yeah. So when you are asked to differentiate a sum with respect to x, you can just take the derivative with respect to x, right there in the formula, and it'll work. It's just the shortcut of writing it out, differentiating, and writing it back. It's the same thing as if you were to just differentiate right there in the formula. Does that make sense? Oh, yes?
Is there a reason why where n starts change between those two?
You know, we could have, that's why I say we could have done an n equals 0 here and kept it with n equals 0, but then you wouldn't have seen the pretty formula as nicely. And if you kept an n equals 0 here, you'd end up with a 0th term, which would be 0 plus. So you know, you really could do a 0, and it'd just be 0 plus. Yeah, that'd be fine if you want to start with 0. And actually, getting into where it starts is going to play a role in a couple days. So yeah, so it's good that you're paying attention to it. Yeah. Did you start yours with 0? No, you start with 1. I start with 1 just because I'm looking at first term and that's what my brain is thinking. But certainly you could start with 0 and have it be, because you'd be times 0 anyway, so it'd be okay. Okay. Very good. Good questions. Good thinking. All right, so, blah, blah, blah. Hey, okay, so, and yes, you can make a conjecture on, yes, you can differentiate a power series just by differentiating the series itself. Oops. My board is up. Okay. Hey, I want you to take a minute now and integrate all of the terms of your original series. Take a second and integrate. And then you're going to write the integral in sigma notation. I wonder what it will be. Well, technically you don't have to, but it will help
We
in
get out at
your
like
learning. If
1-ish though.
go ahead and do these.
Bucks if we get early.
Yeah, 1, 2,
Yeah.
So are you counting how many times it goes back?
3.
3, that's 5.
Yeah.
You look for like 2.
Yeah. And I'm not counting the times that I say something first and then it's only unprompted look backs.
Yeah, this was a prompted look back at the question.
Not by me.
Gentlemen, Victor, please.
Oh, I thought we were differentiating what we had already, or I'm sorry, I thought we were differentiating.
No, we're back to the
We're back to the
original.
original, and we're integrating that. Okay. And we just say it's a
killer type. Come on.
Because you just said that.
I'm trying to create my Yep.
You do you.
I don't want to do myself.
I know how to do it.
Never mind.
Where you still got
Well, you're ahead.
Well, yeah.
Even ahead. When you take.
Did she tell you what happened?
Do I do that?
Nobody tell you?
Okay. Do you see the original up there? Okay. So when you take the integral, you have to
It's not like
This is what you need to become. By half an inch.
You're right, it's actually of the length and you end up doing
Oh, okay.
Maybe.
all I have is mascara.
Oh, it's like when you, yeah.
I really like the look
That's
of
why I
it.
messed up. I kinda-
No, I'm stopped right now.
Keep going.
I haven't used it though.
Oh, I just got, does writing matter? Writing is.
5 actually.
Oh, wow. Yeah, I got like a 20. I think so. I mean, I think to turn it in, some colleges.
I'm on fire with it. Yeah, you know what?
So we have.
I think sure it's 0.
Alright, good. So, if you actually, quite done, if you actually took the time to differentiate or to integrate the polynomial, hey, I bet I know something a lot of you forgot. There's a C, right? Unknown constant. Oh, and we have a question. I bet I know what the question is. Bethany, what's your question?
When you, that doesn't work,
Tell me why.
because it's an x minus c to a power, so every time you multiply that out so that you can integrate it, you end up with like x squared, x to the first, x to 0, or x cubed, x squared, x to the first.
Oh, okay. So if you think about integrals,
It's so bright, it's so crazy.
X minus 5 to the 8th over 8. That's C.
right? Remember that when it's just x plus constant, you would do a u substitution. You'd end up with the exact same thing. It really does work. Your brain now is trying to expand all of those binomials, but it really mathematically works out correctly.
Okay.
Yeah, it really does. Go back to your u sub days and do a u sub on all of them, and you'll see that it's you'd let u equal x minus 5, so you'd have u to the 7th. So you
Another
need
one,
to break
another
this
one.
up.
I know, that's
Okay,
4.
that was not the question I was looking for, but it's a good one. Yeah, don't let the quantity trick you. It still works, right? If it's x minus c and that's just a constant, the integral is x minus c to the 3rd over 3, right? It still works. But there is one term that should be bugging you a little bit. Terrence.
C, like how does that get incorporated into the solution?
Oh, the unknown constant?
Yeah.
Oh, that's not the thing I was hoping would bug you, 'cause that has to be there. Because when you integrate, you end up with an unknown constant, right? Okay, but there is one term that integrates and doesn't integrate to what I have written here. Yes?
Why is it a sub 0 times x minus c?
Okay. Alright, the antiderivative of a sub 0 with respect to x is a sub 0x, right?
Yeah.
I wrote a sub 0 times x minus c. Now, the reason I wrote it was so that we can easily convert from this to sigma, right? Is it legal to have this as opposed to just a sub 0 x?
It's legal.
Why would it be equivalent?
It's constant.
Because a sub 0 c is a constant, and since we have this big unknown constant here, we could just pull it from the unknown constant, since all constants get lumped together anyway. So, yeah, so we're okay. You can go ahead and have it. Yes, that was the thing that bugged me too, but the way that I wrestled with it and dealt with it was I want it there in order to write my sigma, and it's okay because it all just gets pulled from the constant. So, you have, for your sigma, just put the c out front, because you certainly don't want to have the sum of the c's, right? The sum of the c's would still be a big C, but I think it's easier for my brain to just have it outside. So you have c plus the sum, as n goes from 0 to infinity, of 1 over n plus 1 a sub n x minus c to the n plus 1. Yes, Kate?
Is it okay if I used a K instead of a C for the?
Oh, for the unknown constant? Sure, sure. Yeah, because, you know, you do have C's and C's. I just did big C, little c, right? But that's fine. K, yeah, that's fine. Yeah. Good. Hey, take a look at the original sigma. And take a look at our final sigma. Does it match if you were to integrate this? Would you end up with that?
Yes.
Yes, you would. Yes, you would. All right, so yes, we're all good. So yes, conjecture about the integral of a power series. The integral of a power series is the integral of the power series, right? Okay, so it all works. Okay, so now we have an actual power series. No unknown constants, no C's, no whatever, just a true series. Here's a lovely power series, x to the n over n. I want you to take 2 minutes, apply the ratio test, and figure out the radius and interval of convergence for f. We did this like 15 times this weekend. You should be old pros at this now.
Oh.
Oh, you got it.
That was the thing that
Picture
like
this.
a minute ago.
You
It's not live
get
for
for
lunch.
the x, absolute value of that,
And then like the prime at the end.
one part equals 1, so that
Then
goes
that's
negative 1 to x
I'm
over
not looking for rams and
1. This is the actual value, right?
everything's
So,
Negative 1 dive.
what do you get this? It's plus or minus.
Once you get that open interval of convergence, what do you have to do? Test those endpoints.
Yeah, x minus, then it's negative 1 to 1. So now you have to test endpoints.
Oh, hey.
Negative 1 to the n over n. And 1 to the n value. What's that? You get rid of negative 1 to n. Then just, you'd forget about it, it's going to be 1 over n. 1 over n over n.
Cancels out, you get x.
So to start off, did you all get, what was your radius? 1.
The other one diverges, so it
So
doesn't.
you all got a radius of 1,
Yo, can you sit down?
and then a starting interval from negative 1 to 1, and now you have to test your endpoints, right? So you plug the -1 into the original function, and you get -1 to the n over n. What kind of a series is that?
Alternating.
It's an alternating, right? Alternating series, the limit just has to approach 0 and it converges, right? So for the -1, as long as you plug in, you ignore the -1 part, you just get the limit of 1 over n, and it does approach 0. So the function converges based on the alternating series. What about if you plug in a 1? What kind of a series do you get? What is 1 to the n? 1. So what is the sum of 1 over n? What kind of a series is that? That's a p series, right? You apply the p test. Does 1 over n converge or diverge? It diverges. What's the name of that series? What's the name of that specific series? That's the harmonic series, right? Okay. So we end up with the harmonic series which diverges, and therefore our final integral. Oh, I'm not having good luck with this word today. It's -1 inclusive, 1 exclusive. So -1 less than or equal to x less than 1. Is that okay? Good. All right. Hey, that's just review. Why would we spend time doing review? Oh, I don't know. Okay. Hey, let's take a second for, oops, I just showed it to you. Pretend you didn't see it. Okay. I want you to take a second and find f prime of the sequence you just did. And then I want you to find the radius and interval of convergence for f prime. There's a line that's really?
I might. I feel like yeah.
How much fun is that? Almost some. Almost.
Alright, I've got a question. Harmonic times.
I gotta tell you, there was a lot of different mathematics besides that were quite
Basic geometry and algebra. I wish algebra took a while to get started. I know at 0 is a very long time to get straight into that. So
Yeah.
It wouldn't be a competition.
Okay, so, alright, so you're talking like hundreds of years.
Oh wait, possibly. That's what I know. How close to now can we get up from meeting the best competition?
Because Euclid was 300 years.
Yeah.
And
But he's got me in
right. Archimedes is also around 300.
Oh.
yeah, but I know calculus.
Radius.
See, there's no way you can
But like overall, like if you had to do like a 2K my player, what's my overall rating? Do you?
What's going
I don't know.
I'm asking
You
how
know,
far
that
back in
would
time
be
would I have to go
paper
to
to
the
write.
best statistician in the world?
How far?
Me
That
right
is
now.
fantastic.
Negative
Research paper that we made
billion
for a math
percent.
history.
Yeah.
Yeah, this is like
You know,
math.
she said, well, there are a bunch of different maths that they would
I
do.
used
I'm
to,
like, okay, but if I was thinking
It
of
equals one
my
math
player,
history
Convert to diagonal.
when would I have to my overall rating higher than anyone else's?
curriculum.
Bro, you
Yeah,
can't,
okay,
you
but like,
can't
let's
reach
just
this
go
our
like
meeting,
this.
No, I know chapter 6, no 0.
Geometric
As an accepted high school math.
Bro, I don't even think so. You
So
probably zero and
excited,
then
and I.
Oh, you go to Africa, that'll be like that.
All my school, and they just didn't have,
Yeah.
they couldn't offer it, because we couldn't cover with all the teachers we had all the.
Like it is negative one.
I always.
No, here.
Okay, let's get to work on this, so F prime, you just get nx to the n minus 1, right? The n's cancel, so F prime is just the sum of x to the n minus 1. How nice is that, right? So, when you do your convergence, when you do your ratio test, you end up with a radius of 1. And then, so your interval is -1 to 1. So you test your endpoints. -1 to the n minus 1. There's a couple ways to determine convergence or divergence of this. Tell me one way that anyone tried.
Nth term.
Nth term test. Does this pass or fail the nth term test? Depending on how you look at the nth term test. Tell me what the nth term test determines for this.
The limit is 1, or
Right, this limit, because the nth term test says that the limit of the argument has to approach 0, and if it doesn't, it diverges automatically, right? So this guy, we have -1 to the n minus 1. It's an oscillating limit, right? Right? So because it never approaches 0, the limit does not exist, and therefore this series has to diverge. You could also think of it as an alternating series, right? If you think of it as alternating, then what you end up with is -1 to the n minus 1, think of it times 1, right? So for alternating, you ignore this and just take the limit of what's left, and if it approaches 0, it converges, and if it doesn't, it diverges, and this one approaches 1, so it diverges. So there's a couple different tests that you can use. Either way, you're going to get that this series diverges, so -1 is not included. What about 1? Diverges by what test? Nth term test, right? It's an automatic. So, this is our final interval of convergence, is -1 to 1 exclusive. All right, one more. Okay, so I want you to take a second and find we're going back to the same f of x. I want you to find the integral of f of x. Don't forget your plus c. Find the integral of f of x, and then find its radius and interval of convergence.
Do you always just keep n the same as what it was, or do you ever have to change it? Or like the starting?
You mean like for your original function?
Yeah, just like, right, you just keep it n equals 1.
Oh, yeah, I would. Yep.
Because when we were like, did this back here, you
We changed it to 1, and we were talking about that. Technically, it could have still been 0, and you would have had an equivalent version.
Oh, okay.
Yeah. I think I might change it for next period.
Wait, don't you have to divide by that? So you're not equal?
So here you go.
No, you're talking about for this one? Yeah. So it's not divided by period. Be divided by. Right, that one, you're plugging in here. And it's the same one. So it's also.
Should be,
Give you the radius or the ratio test? Prime.
you know,
Chairman Howell.
just want to do the limit for the ratio.
Every time it's just a
It's in respect to
Oh, that's over X, okay, I see. Alright, good.
You want?
What's up?
Go to state, go into that sweet 16. You Mr. Shipley, right?
Yeah, yeah,
For just ABC?
Yeah, with an
Or
absolute
Ron,
value.
taking test?
yeah.
You're writing
No,
some,
it's
but
pretty
really
easy. I think we all
You would
got
do
it.
it?
infinity with an absolute
Yeah.
value.
90?
Yeah.
Ours is 90.
What? Ours was like 75 or something.
Oh, really?
I don't know, I remember being 90.
Did he, when you turned it in, did he like question you?
No, we didn't question it.
Oh, someone said that when you turned it in, they put the spotlight on you and you have to answer questions.
No, he's probably just like,
Oh,
no, he wouldn't do that. I don't know why yours is 90 question.
ours is 90. If you have 40.
That's not cool, bro, that's like
So
good.
if you plug in, you have one over.
It should be easy, unless it's harder.
Oh, is it
I don't know.
wait, is this yours?
What was
Okay.
it? Did you put it?
Did you
Ours is
determine
75
in
and
your
9.
little comparison?
I'd have to go check, like, it
Or
was,
was it someone said it was at a
So
4.
are you doing the
like a
Dividing
70
one
point test,
over
that's
n,
like-
little
little
so plug in one
So you got
first.
75%.
limit comparison, you have to
yeah,
divide
it was very.
I better get
your
up.
function.
I don't know if it's 90 maybe.
So you're doing it right, yes.
Or maybe it's easier to state. Probably not.
Check and make sure you got the right integral. Do y'all remember the plus C? Oh, okay, alright, good. Alright, I saw a lot of really good ratio tests. And when it all comes down to it, you're just left with absolute x less than 1. So your radius is again 1. Your interval starts with -1 to 1. So when you do the first test and you plug in -1 in, you could use what test? Alternating series, limit without the -1 approaches 0, so the -1 works, it converges. You try the 1, direct comparison test is your best bet, right? That's the easiest one to compare to, because if you compare it to 1 over n squared, this one's always less than 1 over n squared, because this is 1 over n squared plus n. So, because this one is always less, does 1 over n squared converge or diverge?
Convert.
P-test. P-test tells you that 1 over n squared
It's larger than greater than 1, it converges.
converges, because it's greater than 1. Yeah, I know, it's opposite some of the other tests. Yeah, so 1 over n squared converges by the p-test, or, yeah, and so less than converging converges, so this guy converges by direct comparison test. So they both converge, and therefore you have the final interval of -1 to 1 inclusive, includes both endpoints. let's summarize what we've learned and then we'll go to lunch. For f of x, what was the radius?
1.
What was the interval of convergence?
-1 less than equal to.
Wait, which one is this?
The original f of x.
Oh, I think it's equal to less than.
For f prime, 1. For the integral, radius was, and the convergence interval, want to make any conjectures about how they relate? What do you think about the radius?
They're all the same.
Do you think it's always the same for the derivative and the integral?
Yeah.
It is. What about the interval?
Same, different.
Same, but you have to test the endpoints every time, right? Same, but with possibly different endpoint convergence? Very true. So, what you end up with, in summary, and then I will set you free, is the radius is always the same. The interval of convergence will always have the same numbers in it, but the endpoints have to be tested individually for each one. Alright, we will finish this up after lunch.
Okay. As this came south,